To solve this problem requires knowing something called the quadratic formula. That's what we have right over here on the right hand side. Now the general equation that we use to represent this kind of math is a quadratic equation or a polynomial. The general format we use is a times x squared plus b times x plus c is equal to 0. And then we can use this to solve for the unknown variable x, which will be equal to negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. And we can solve the above question using this general format by recognizing that in this case, my a is going to be 2. Instead of x squared, I have t squared. I have a b that's equal to 2. I have, instead of x, I have t. And then I have a c that's equal to 3. So in this case, I can take this quadratic formula and plug in the numbers that I know for the actual problem that I'm trying to solve. So let me plug those numbers in, and I'm going to be solving for t in this case instead of x. And that will be equal to negative b. And if we look up here, our b is equal to 2. So negative b would be negative 2, plus or minus the square root of b squared, and that's going to be a negative 2 squared, minus 4 times a, where in this case my a is also equal to 2. I can see that from the above equation, times c. And in this case my c is equal to 3. And then I need to divide all of this by 2 times a, which if we remember is still equal to 2. So now I need to actually start solving this equation. So I can just start plugging in my numbers and typing them into a calculator or doing them in my head. So I can find t is equal to negative 2 plus or minus the square root of negative 2 squared, which is going to give me 4, minus 4 times 2 times 3. 4 times 2 is 8, times 3 is 24. So that's going to give me 4 minus 24, all divided by 2 times 2 is 4. So I can further keep simplifying this. I have my negative 2 still, plus or minus the square root of 4 minus 24 gives me negative 20, all over 4. And at this point, you've actually found a final answer. Depending on how far you've gone in your class, if you've learned about complex numbers, you might have to factor this out. So how do we do that? Let's take a look. So if you've learned about complex numbers, you should know that I is equal to the square root of negative 1. Normally we can't take square roots of negative numbers. This is where complex numbers come into play and using this I term. So I can rewrite this as t is equal to negative 2 plus or minus the square root of 20 times the square root of negative 1, all over 2. And now I can recognize that I can plug in this I. So I can turn this into a complex number and find t is equal to negative 2 plus or minus the square root of 20 times I, all divided by 2. I can further simplify this even more. I can specifically simplify this stuff under the square root. So I can factor that out. I can figure out what two numbers to multiply together to get this. So I have my negative 2 plus or minus the square root of 5 times 4. That gives me my 20. This is the same thing. I'm just kind of simplifying it, breaking it down into smaller numbers, times my I, all divided by 2. I can recognize that I can actually take one of these square roots. I can take this and I can rewrite it as t is equal to negative 2 plus or minus the square root of 5 times the square root of 4 times this I, all divided by 2. I know what the square root of 4 is. The square root of 4 is going to give me 2. So I can plug that in. So why not plug that in? And I get negative 2 plus or minus 2 times the square root of 5 times I. Where all I've done here is, instead of writing square root of 4, I write that as a 2. And I've just stuck it out front. And all that divided by 2. And now I can see I have a 2 in every single term of this numerator. I have a negative 2 up here, plus or minus this positive 2 square root of 5 times I. So that's going to cancel with my denominator. All those 2's cancel out and give me 1's. So I end up with my final, most simplified answer of negative 1 plus or minus square root of 5 times I. So those are my two solutions. I can have negative 1 plus the square root of 5i, or negative 1 minus the square root of 5i. This problem looks a little bit different, but a little bit similar to the one that we previously solved. So there's a way that I can solve this. I can actually make this look a lot like the previous question that I just did. I have an s in every single term of this, this equation. I have a 4s cubed plus a 4s squared minus a 15s. So I can actually factor out an s. I can take an s out of everything. If I do that, I end up with s times 4s squared. So I'm factoring an s out of every term on this left-hand side of my equation. So I have 4s squared plus a 4s. Remember, I'm factoring out one s out of every part. So this s cubed became an s squared. This s squared is going to become an s. And now when I take an s out of my 15s, it would become just plain 15. And that's going to be equal to 0. So now I have a quadratic equation, which we can solve using the quadratic formula. Remember, ax squared plus bx plus c is equal to 0. And I have this little s out front still. And what I notice is this s is multiplied by my quadratic formula. I have an s times all of this. Quadratic formula has to be equal to 0. So that means that s itself can be equal to 0. If I plug in a 0 here, then I end up with 0. So that's one of my answers after I factored this out. I have two things multiplied together. If one of those things is 0, in this case my s, then I get 0 as my answer. Now I also have to solve the second part of my multiplication problem. What if all of this stuff is equal to 0 times whatever this s is? It could be anything. I would still get a 0. So that's where my quadratic formula comes in. And remember, the quadratic formula tells us that x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And in this case, we can figure out what our a, b, and c's are. For this particular problem, it looks like our a is equal to 4, our b is equal to 4, and our c is equal to negative 15. So those are the numbers I'll be plugging in. And instead of x, if we look really closely, I have, it looks to be an x. So I can plug in for my s and find s is equal to negative b. In this case, my b is 4, so negative 4 plus or minus the square root of b squared negative 4 squared minus 4 times a. A in this particular problem is 4 as well, and c was equal to negative 15. And that's all going to be divided by 2 times a, where my a again was equal to 4. All right, so this is the equation we're working with. Let's just start plugging in and start simplifying our numbers. I got my s is equal to negative b, which was 4, plus or minus the square root of b squared, negative 4 squared. This gives me 16, minus 4 times 4 is 16, times a negative 15, all divided by 2 times 4, which is 8. Keep working this, keep simplifying. I do it step by step. You can combine some of these steps if you can think that far ahead. I'm an idiot and cannot. So negative 4 plus or minus square root of 16 minus 16 times negative 15. Type this into your calculator and you will find that it is. So 16 times negative 15 gives me a negative 240. All divided by 8. Just keep doing the addition and subtraction. I'm doing it step by step. Like I said, you can combine things. So 16 minus negative 240 is going to give me 256, all divided by 8. I can find what the square root of 256 is with a calculator very easily. Hopefully they're letting you use calculators. And I find s is equal to negative 4 plus or minus 16, all divided by 8. So now I have two values for s. S1 can be negative 4 plus 16 over 8, which when we simplify that out gives us 12 over 8, which will be equal to 3 over 2 when we simplify that all the way. And I find S2 is equal to negative 4 minus 16 divided by 8. And that's going to be negative 20 divided by 8, which we can also simplify to give negative 5 over 2. So these are our two answers, and we need to combine these with our very first answer from the last little screen that we had up. Also s equal to 0. So this brings up an important point to make, an important point to notice. We started with a very, very first part of this whole sequence of problems. We had a t squared. When we had the t squared, we had two different answers. And then we solved another problem, this current problem, which involved an s cubed. The s cubed had three answers. So when you have these kind of formulas, these kind of quadratic formulas, these kind of polynomials, whatever the highest exponent is, in this case 2, or in this case it was actually 3, in the last case it was 2, the highest exponent tells you how many answers you should have. So when we had an exponent of 2, we had 2 answers. Exponent of 3, we had 3 answers. If I were given a problem that had, say, q to the 5th power, then I would expect that there are 5 different answers to that particular question, in general. So for solving this inequality, we're going to want to distribute our multiplication in and try to get rid of multiplication signs. We want to have just adding and subtracting involved in our algebra. So I can distribute this value, this 4 value, into my parentheses. So that 4 has to be multiplied by the x, and the 4 has to be multiplied into the 3. Same thing with this 3 has to be multiplied into the x, has to be multiplied into the 2. We call this the distributive property of multiplication. So we got 4x minus 4 times 3 is 12, has to be greater than or equal to 3 times x is going to give me 3x, and 3 times negative 2 is going to give me negative 6. Now I can start shuffling things around. I can get this equation so I can solve it, and then when I'm solving an equation, I want to get like terms on the same sides. So I want to get all my x's on one side and all my non-x's on the other side. So to do that, first, I want to get all my x's on the left-hand side. No particular reason. I can do it either way. That's just the way I'm going to solve it. So to get rid of my x on the right-hand side, to get rid of this, I need to subtract it. So I need to subtract a 3x. But if I do it to one side in an equation, I have to do it to the other. So I have to subtract 3x from both sides. When I do 3x minus 6 minus 3x, my 3x's cancel out, and I end up with just a negative 6 on the right-hand side. And now, on the left-hand side, a 4x minus a 3x is going to give me just 1x left. And then I still have my negative 12. I'm trying to get that x by itself, so I'm going to get that 12 over to the other side. To do that, I add 12. Negative 12 plus 12 will give me 0 and gets rid of that 12 on the left-hand side. If I do it to one side, I have to do it to the other, so I add plus 12 to the right-hand side. When I do this, I end up with my negative 12 and 12 canceling. I have an x. It's going to be greater than or equal to 12 minus 6, which is equal to 6, and I have my final answer. So the key here was really to distribute your multiplication values into each part of the parentheses, and then to get x by itself and solve for x. Get common terms on common sides, and remember, whatever you do to one side of an equation, whether it's subtracting 3x from both sides or adding 12 to both sides, whatever you do to one side, you have to do to the other. So to solve this one and simplify it involves a couple tricks. The first trick we want to do, we want to get rid of this 2 plus I in the denominator, specifically this I. We don't like having i's in the denominator. That's not simplified in math, so we want to get rid of that. We want to move it up top. And to do this, the trick is to multiply by something called the conjugate. Now the conjugate looks very similar to this term, this 2 plus I. The conjugate of 2 plus I is 2 minus I. It's the opposite sign I term. Okay, you can look this up. You can find some information about this. The site that I'd recommend is something called Purple Math, and they have additional explanations on how to do these things and what they all mean. But we're going to multiply by the conjugate. But I can't multiply by just 2 plus, by just the conjugate on the bottom to get rid of it. I have to multiply by in essence, 1. If I multiply by 1, I'm not really changing it. I'm just kind of shuffling things around and trying to get this 2 plus I out of the denominator, something we have to do in algebra. So I can multiply by the conjugate that's equivalent to 1. So that would be 2 minus I divided by 2 minus I. So just to go in a little more detail on this conjugate idea, on this conjugate thing, let's say I had 1 over 3 plus I. If I want to get rid of the 3 plus I in the denominator, I will multiply by the conjugate, which is 3 minus I, divided by 3 minus I. Let's say I had 4I divided by 3 minus 5I. Again, I want to get this complex number, this I, out of the denominator, so I would multiply this by the conjugate 3 plus 5I over 3 plus 5I. So that should provide enough examples of what the conjugate is. I just take the whatever term has the I in it and I flip its sign. Okay, hopefully that makes sense. If not, try Purple Math or email me more questions. Happy to try to answer those. And what I need to do now is I need to actually perform this operation, this simplification, whether it looks like it's simplifying or not. So I need to multiply these numbers together. And when I do that, I'm going to carry this down here and do the multiplication right underneath. I have 4I times 2 minus I up top, and on the bottom I now have 2 plus I times 2 minus I. And this is the second little trick that we have to use. It's something called the FOIL method. And this is how you multiply together two terms that are in parentheses like we see here. Like this 2 plus I times 2 minus I. The FOIL method. The FOIL method If you haven't learned it yet, it's very useful, and it stands for first, outside, inside, and last. Okay, so how does that work and what does that mean? It means that we're going to multiply terms together. And we're going to first, to simplify this multiplication on the bottom, to actually multiply these numbers together, we have to multiply each number by every other number. And the code to do this is to do... So this shorthand FOIL method tells us we first multiply the first numbers, and then we multiply the outside numbers, then we multiply the inside numbers, and finally we multiply together the last numbers. So let's do this out. Let's do this multiplication. We have 4i times 2 minus I. Up top still, don't need to multiply those any strange ways. Since we have this two numbers added together in parentheses and multiplied together, we have to do the FOIL method. The first two numbers. First is going to be 2 times 2. That's going to give me 4. Then we're going to have the outside numbers. 2 times I. That's going to give me plus a 2i. Plus a negative 2i, sorry. That negative comes from the 2 times the negative I. So that's, again, a negative 2i. And then we have the inside numbers, I times 2. So that's going to be plus a 2i. And then we have the last numbers, which is going to be I times negative I. So let's do plus an I times a negative I. Okay, and now I can start simplifying this a little bit more. I have up top, I'm going to distribute this 4i in to the 2 and into the I, distributive property of multiplication. So that's 4i times a 2 minus a 4i times an I. And that's going to be all divided by 4. And if we look here, I have a negative 2i plus a 2i. So those two, that negative 2i plus 2i cancel each other out, and I end up with plus an I times a negative I. Now I need to think about what that I actually is. I is equal to the square root of negative 1. So I times I is equal to the square root of negative 1 times the square root of negative 1, which is just going to be equal to so the square root of negative 1 times the square root of negative 1 gives me negative 1. So I squared is equal to negative 1. And that's pretty much what I have right here. I times a negative I. So that negative I that I have will cancel out this negative for my negative 1, and I'll end up with just 1. So let's see that a little bit more clearly. So let me wipe the screen and get that reshuffled so we can solve this out. So let's see this again, maybe with a little bit more room. Hopefully this is making sense. I times an I up top in the numerator. I is the square root of negative 1. So we have the square root of negative 1 times the square root of negative 1. Take two square roots and multiply them together, and they kind of cancel each other out. So I end up with just a negative 1. So up top, I'm going to have 4i times 2. 4 times 2 is going to give me 8. So let's go ahead and just do that. Let's multiply this 4 and this 2, and we get 8 times I. That's going to be minus 4, and the I squared is going to give me negative 1. And then in the denominator, I'm going to have 4 plus I times negative I. Let's see what that is. I times a negative I. And what I can do, I can take this negative 1 all the way out front. I can distribute things, I can shuffle things around as much as I want, as long as I keep all the multiplication things things the same. As long as I can multiply it back out to get this same I times negative I that I start with. So this is negative 1 times I times an I. And I recognize that I times I is negative 1. So this is going to give me negative 1 times a negative 1. Negative times negative gives me a positive 1. So that negative right there results in me getting a positive 1 instead of the I times I, which is equal to negative 1 that I have up in my numerator. Lots of little arrows shuffling us around. So this 4 plus a 1. And I end up with my final answer, which is going to be 8 times I plus a 4, where my negative and my negative multiply together to give me positive 4, over 4 plus 1 is equal to 5. And this gives me my final simplified answer, where in this case, the purpose of simplifying is to get rid of the i's in the denominator and bring them up top. So for this problem, we're going to solve similar to how we solved the third problem and kind of get rid of the fractions and get all the x's on one side and everything else on the other side. So to do that, I need to simplify this thing a little bit. So let's shuffle this around so I can actually write with this. And to get these x's by themselves, the first step is to get rid of fractions. I want to get rid of fractions, and I really don't like working with fractions that have expressions in them, have addition and subtraction inside of them. So I'm going to multiply this times 1 minus 2x. And I can do that, and when I do, I see that it will cancel with the denominator. But I can't just do it to one side. In algebra, if you do it to one side, you have to do it to the other. So I have a 1 minus 2x on the right-hand side as well as the left. So now I have, when I multiply this out, 1 minus 4x on the left-hand side, I've canceled that denominator out, is equal to 9 over 8 times 1 minus 2 times x. Now I still have a fraction in there. I don't like working with fractions, so I'm going to try to get rid of that by multiplying this right-hand side by 8. And my 8's will cancel. If I do it to one side, I have to do it to the other, so I have to multiply my left-hand side by 8. Here I'm just getting rid of the fractions so I can start playing with the equation a little bit easier. I want to multiply this side by 8, so I need to distribute that 8 into both parts of the variables that are in the parentheses there. So I have 8 times 1, it's going to give me 8, minus 8 times 4x is going to give me my 32x, and that's going to be equal to 9. And I'm going to just go ahead and distribute this 9 in. 9 times 1 is 9, and then if I distribute to the other element in there, I have 9 minus 9 times 2x, which is 18x. Now I'm going to get x's by themselves, so I can add this 18x over to the other side. Doesn't matter which one you do, I just picked the 18x. I could move the 32x to the other side. So my 18x's are going to cancel on the right-hand side, and they're going to add together on the left-hand side. So I'm going to end up with 8 minus, so negative 32 plus 18 is going to give me 14x. And that's going to be equal to 9. And then I still need to get it by itself, so I need to subtract 8 from both sides. Okay, so I subtract my 8 from the left-hand side, and that leaves me with just a negative 14x on the left-hand side. Leaves me with negative 14 times x. And on the right-hand side, a 9 minus 8 gives me 1. So this tells me that my x is equal to 1 divided by negative 14. And if you're ever interested or in doubt, you can actually take this x and I can plug it in up at the very top into this original equation that I started with, and it will give me the correct answer. And I checked this out, I plugged in for my x, and sure enough, you get the right answer. So this is a problem that would probably trip up a lot of my students, but it's actually probably one of the easier ones that we have. The only trick is you have to treat letters like numbers. And at this point, the only thing that we can worry about is solving for b. That means we want to get b by itself. So the first step in doing this is to get rid of any multiplication. I want only addition and subtraction in my little formula. So first, I have this 1/2 times h times b plus b prime. If I want to get rid of these things, the first thing I can do is I can distribute this 1/2 h into my parentheses. So I can use the distributive property and shove that into both terms. So I end up with a is equal to 1/2 h times b plus 1/2 h times b prime. I want to get b by itself, so I can subtract 1/2 h times b prime from both sides. I'm asked to solve for b, so that's why I'm subtracting the b prime terms over to the other side, trying to get rid of them on this right-hand side of the equation. So those are going to cancel out to give me 0 on the right-hand side, and on the left-hand side I end up with a minus 1/2 of h times b prime. And that's going to be equal to 1/2 of h times b. Now, to further simplify this, I get b by itself, so I can actually divide both sides by 1/2 of h. Divide both sides by 1/2 of h. So the 1/2 h is going to cancel on the right-hand side, and I'm going to be left with b is going to be equal to a minus 1/2 of h times b prime divided by 1/2 of h. And there is your final answer. So I'm not entirely certain how they want you to solve this, how they want this done. I'm assuming that they want you to write it in terms of things that you can take square roots of, and you might still be left with other things that are left over with some remainders. So I need to kind of write this out in terms of different quantities. So my 20, let's cover that first. I can actually rewrite this. Maybe this is the easiest way to do it. I can rewrite this as the square root of 20 times the square root of x to the 5th times the square root of y to the 7th times the square root of z to the 4th. Okay, so I can deal with each one of these terms individually. Square root of 20, I can rewrite that. I can try to simplify that as the square root of 5 times 4. 5 times 4 gives me 20. And I see that 4 is actually a very nice square root. The square root of 4 is 2, so I can get rid of the square root there and end up with 2 square roots of 5. And that's the simplest you're going to get that term. Then I have the square root of x to the 5th. How am I going to simplify that guy? Well, this is going to be equal to the square root of x squared times x squared times x. Okay? When I'm factoring out, when I'm multiplying exponents, I actually add them. So this is an x squared times x times x, and there's an implied 1 here for my exponent. I'm multiplying exponents, so I'm actually adding the exponents themselves. So x squared plus times x squared is x to the 4th times x to the 1st gives me 2 plus 2 plus 1 is equal to 5. Maybe that makes sense. Hopefully it does. So the square root of x squared is going to give me x. Square root of x squared is going to give me x. And then I still have a square root of x that can't be simplified out. Can't pull an x out of there. So next we're going to have y to the 7th. So that's going to be the square root of y to the 4th times y to the 3rd. 4 plus 3 is equal to 7. And the square root of y to the 4th is going to be y squared. And then we still have the square root of y cubed. Okay, I can simplify that a little bit more to be y squared times y to the 1. So this is going to give me y squared times the square root of y squared is going to be y times the square root of y. And then we have our z, the square root of z squared, or z to the 4th. Square root of z to the 4th is going to be simply z squared. And now I can add these all together. I can combine them all to get my final answer. So I'm going to combine 2 times square root of 5. 2 square roots of 5 times x times square root of x times square root of x times y squared times y, which is going to give me y cubed times the square root of y, and then times a z squared. And I can further simplify this by combining things that are in parentheses. So I get a 2 times an x squared, just combining these, x times x gives me x squared, times y cubed times z squared, just bringing all these down. And then all the terms that are actually under the square root of 5, the square root of x, and the square root of y, I'll just put them all under one square root. So square root of 5 times x times y. And this, I suspect, is the final answer that you're looking for. So what I did there is I just broke it down piece by piece and simplified as much as possible. Okay, this one's not going to be bad at all. This one is going to involve something that we've already done. It's the FOIL method. First, outside, inside, last. So we have the first numbers to multiply together. It's going to be square root of 8 times the square root of 2. The first numbers, we have the outside numbers, square root of 8 and 2 times the square root of 8. So that's going to be plus the square root of 8 times 2 square roots of 8. Then plus we have the inside numbers, which is going to be negative 2 square root of 2 times square root of 2. We have to make sure we take note of that negative out front, plus a negative 2 square roots of 2 times the square root of 2. And then we have the last terms, the negative 2 square root of 2 and 2 square root of 8. So plus, again, that can't forget that negative 2 square roots of 2 times 2 square root of 8. Then we can multiply these numbers together. Square root of 8 times square root of 2 is square root of 16, plus 2 times the square root of 8 times the square root of 8 is going to give me 8, plus a negative 2 square root of 2 times square root of 2 is going to give me 2, and then plus a negative 2 times 2 times 2 is going to give me my negative 4, and then I have square root of 2 times 8, 2 times 8, which is 16. Square root of 16 we can simplify. 4 times 4 is 16, so square root of 16 is 4, plus 8 times 2 is 16, plus negative 2 times 2 is negative 4, plus negative 4 times of 4. And negative 4 times 4 is going to give me negative 16. So I have 4 plus 16 minus 4, or plus a negative 4, plus the negative 16. And the negative 16s cancel each other out, and negative 4s cancel each other out, and I end up with 0. So this one's not too bad. It's a very, very long, involved way of finding what 0 is. Okay, for this one, adding complex numbers. How do we do that? Well, the first step, we're going to want to distribute this negative into both terms inside of this parentheses. So I have a 3 minus a 2i. Distribute that negative 1 in to get a negative 2. And I have to bring that negative into the second term as well. So I have a negative 1/2 I. And I can start combining like terms. If I have an I in it, that means I can combine them. If I don't have I's, then I can combine them. But I can't mix and match. So I can combine this 3 and this 2. 3 minus 2 is going to give me 1. And I can also combine this negative 2I minus this 1/2 I. I combine these two, and I get negative 2 plus 1/2, which is 2 plus 1/2 is negative 5/2. So that's negative 5/2 I. And that would be our final solution. The important point to keep in mind here is that I only combined numbers with other numbers and only combine complex numbers with other complex numbers. Piece of cake. So first step, we need to know what these little bars are. These bars stand for something called the absolute value. So that means that we're only interested in the positive value. So we have the absolute value of 2x plus 1. I'm going to get this isolated. I'm going to get this by itself, like it's its own little term. Minus the 3, to get rid of that 3, I can add 3 to the left-hand side. But as long as I do it to the left, I have to do it to the right, so I add it to the right. And I end up with negative 2 plus 3 is going to be equal to 1. So I have my absolute value of 2x plus 1 is going to be equal to 1. So what does that absolute value mean? How do we actually solve this kind of equation? Okay, to take this equation from here and actually solve it, we need to get rid of those absolute value bars. And to do this, I need to recognize that I can have negatives involved. So what does that mean? That means I can have one of two solutions. I can have 2x plus 1 is equal to 1. That's the solution that I expect everybody would be able to find. The other one is to recognize that that absolute value just makes your negative values positive. So to account for that, you need to take the negative value of the left-hand side of the equation. So negative 2x plus 1 with 2x plus 1 in parentheses is also equal to 1. So that's what that absolute value means. The absolute value means that you take the regular expression and set it equal to 1, and you also take the negative of that expression and set that equal to 1. So this will give us two solutions for our problem. You should have two solutions when you have absolute value involved. So I end up with 2x. If I'm going to solve this equation, I need to subtract 1 from both sides to get my x's by themselves. So I subtract off the 1 from the left-hand side and get 0 for the numbers and end up with just 2x. And then 1 minus 1 is 0, and I get x is equal to 0. So if x is equal to 0, I get the answer that I'm looking for. But I also need to come over here and use my negative solution. That absolute value, remember, regular expression and negative of the expression. So I need to distribute this negative in. I distribute my negative into my 2x and into my 1, and I have with negative 2x plus negative 1 is equal to 1. I want to solve for x, so I get x by itself, add 1 to both sides to get rid of it on the left, and I end up finding that negative 2x is going to be equal to 2. So that tells me that x is equal to 2 divided by negative 2, so x is equal to negative 1. And if I plug in either of these values, either this 0 or this 1, into my original equation, I will find the answer that I am looking for. In other words, I'll find that both can plug in to this upper equation and give what they should. So final algebraic equation to work with. When I have a square root and I'm asked to find what an x is, I can work with this by first kind of getting rid of any square roots. To get rid of square roots, I can square this left-hand side. There's nothing saying I can't, as long as I do it to both sides of the equation. In algebra, you can do anything to any equation as long as you do it to both sides. So I square both sides and I find 10x minus 5 is equal to 5 squared, which is just going to be equal to 5 times 5, which is 25. Now I want to get my x isolated, get x by itself, so I'm going to add 5 to both sides. That gets rid of my 5 on the left, and I'm left with just a 10x, and that's going to be equal to 25 plus 5, which is 30. Now I still want to get x by itself. I can divide both sides by 10, divide both sides by 10. My 10's cancel on the left, and I get x is equal to 30 divided by 10, which gives me, when I simplify it all the way out, 30 divided by 10, x is equal to 3. So the key here with the square root is to get rid of that square root. I did that by squaring both sides of the equation and then just solve it like a normal algebra problem. Lickety-split, piece of cake. Feel free to email me if you have any questions. It'll help if you just specify which problem was confusing, or if you give me say maybe a time in the little video that didn't make sense.